Another topic is also related to derivative, which is called elasticity of demand. So elasticity of demand says that increasing the price of a product can impact the revenue to the seller. If we have more price, your revenue will go up. The increased price may result in sufficient decrease in the number of items sold to reduce the total revenue. So the increased price may affect the demand. So demand will go down. So it may decrease the number of items sold, and ultimately it can decrease the revenue as well. So at one side we are saying that increasing price may increase the revenue, but in the second paragraph we are saying that if price will go up, demand will go down, so it may impact the revenue can go down. So which case will hold? So that is what we need to figure out in elasticity of demand. On the other hand, increase in price might lead to an increase in the revenue. Economists use the notion of elasticity of demand to study the relationship among price, demand, and revenue. So defining the relative and percentage rates of change. Definition: relative and percentage rate of change. The relative rate of change of a function. For example, if you are given any function f of x, its relative rate of change is the derivative of the function and divide it with its function. So this is the definition of, if you want to find the relative rate of change. For example, you are given a function, let's say f of x equals to 2x square. Its relative rate of change will be, derivative of 2x is 4x, so relative rate of change will be f dash of x over f of x, which is 4x over 2x square. You can simplify it, so it is 2 by x. So the percentage rate of change, you can simply multiply this formula with 100. You can get percentage rate of change. The alternate form of the relative rate of change is called the logarithmic derivative. Because we didn't discuss logarithmic derivative, I will explain it when I will solve some examples, that what is logarithmic derivative. For the time being, you can just ignore it. A stock broker tells you about a stock where each share increased by this from December this to December this. That amount of increase captured your attention enough to have you consider purchasing shares. She also told you about a stock where each share increased by this amount over the same period of time. Now you can see the difference of amount. That amount of increase did not seem to capture your attention so much. Any comparison of these gains that does not include the price per share of the stock for the calendar year omits an important basis for comparing. How can we compare these gains? The stock where each share increased by this had a per share cost like this, and the stock where each share increased by this had per share cost equals to dollar this. The relative rate of change in these values factors in the gain with the cost of stocks to form a valid basis for comparing. The relative rate of change is the price change in one share, the price of one share. So here, first stock, the relative rate of change is 45,000 over 249 like this. So this is, if you multiply it by 100, you will get the percentage rate of change. The second stock is 0.524. So you can see that apparently the second one was lower, but it is giving us a more increase, more gain. So the first stock share price is this, has lower relative rate of change than the second share price, which is 113. An investor who purchased one share of the first stock for this would have gained 45 this. Had they purchased this of the second stock about this, the gain would be about 130. Although the dollar amount gained per share was substantially large for the first stock, the relative rate of change was much higher for the second stock. So here you can see a table. A table gives you the GDP of domestic product expressed in billions of dollars and US population. Again, this year this GDP is this, population was this, and similarly we have GDP against the population. A model for the GDP is f of t. If we write this model into a linear equation, it will be like this, where t is the number of years since 2000. Find the graph, the percentage rate of change. The percentage rate of change, note that the model value of the treasury function is increasing, so the percentage rate of change, we will simply take its derivative uh, and divide it with the function. So if you take its derivative, like f dash of t is 209.5, and now we divide it f of t over f of t is 209.5 over 209.5t plus 11361. So percentage rate of change, we multiply it with 100. So you can see here it is like this, and now we can show it in a graph as well if you want to draw the graph. Elasticity of demand is used by economists to answer the question, when does an increase in price lead to an increase in the revenue? Because as I said earlier, if you increase the price, demand may go down, which can impact your revenue. But when does an increase in price leads to an increase in revenue? So the elasticity of demand, let price P and demand X of a product be related with this formula, x equals to f of p, then the elasticity of demand at price will be denoted by this minus relative rate of change of the demand. We have just seen that how to find relative rate of change. Relative rate of change means f dash of x over f of x divided by relative rate of change of price. So here it will take this formula, this form, and if we solve this, we can further write it in this form, and the ultimate formula will become minus, this will be minus p times f dash of p over f of p. So if you don't understand this, which would be difficult for you because we didn't discuss the derivative of logarithmic function, so this is the formula, minus p f dash of p over f of p. That is the elasticity of demand. This is the formula for elasticity of demand. You can see this is the formula for elasticity of the demand. If price and demand are related with this equation, then the elasticity of demand is given by this formula. For example, if the price P and demand X for the product are related by the price demand equation with this, so we can write it X equals to 10,000 minus 500p. So it means that E of P is 10,000 minus 500p. We need to find elasticity of demand, so it is equals to, you can see its formula. To find the E of P, we express the demand X as a function of the price P by solving the price demand equation. This is very important point. To find E of P, we express demand X as a function of P, like I did. We express demand as a function of P to find E of P. So E of that is why I wrote E of P equals to 10,000 minus 500p. You can see that x equals to 10,000 minus 500p, or we can take out 500, which is this. So this is your E of P. Okay, so now here what we can do, this means that price increasing, the demand for the item decreasing. The demand x is a decreasing function of price. When price will increase, demand will decrease. Conversely, lower price results in increased demand. This is consistent with observed price demand behavior in the market. If you increase P, here, your X will go down. That is what he is talking about. Now this is the formula. You can simply substitute the results into this formula. As I said, f dash of P is P times minus 500 and f of P is this. Now if you solve this, it will be 500p over this thing, which is P over 20 minus P. So use E of P to find and interpret. When E of 4 is less than 1, like you substitute P4, you will get 0.25. When you substitute P16, you will get, this means that, for example, if the $4 price changes, if you change the price by $4, the 10%, the demand will change by approximate 0.25 times 10%, which is 2.5. Similarly, if you make it 16, which is again equals to 4, which is greater than 1, we compare it with 1, that either it is less than 1, either it is greater than 1, or it is equals to 1. So again, this means that the 16 price changes by 10%, the demand will change by approximately 4 times 10%, which is 40%. And if it is 1, it means that it is ineffective. This means that the $10 price changes by 10%, then the demand will also change by approximately 10%. Now, inelastic demand, when elasticity of demand is positive but less than 1, like if this condition fails, then demand is described as having inelastic demand, means that it does not matter. In this case, demand is not sensitive to changes in price. That is, a percentage change in price products, a smaller percentage of change in demand. For example, when we are talking about necessities like food, if you increase the price of food, the demand will not go down. You have to eat, you have to buy rice, you have to buy wheat, you have to buy fruit in order to live. Either whatever the price is, it does not matter. So in that case, E of P would be less than 1 or greater than 0. So which means that demand is inelastic to price. Price does not affect the demand. If you increase the price, demand will remain same, and you will increase your revenue. When there is inelastic demand, the price increases will increase your revenue. If you increase revenue, if you increase price, your revenue will go up. And elastic demand, when E of P is greater than 1, means when elasticity of demand is greater than 1, the demand is described as having elastic demand. For example, if you increase the price of iPhone too much, the demand will go down. You cannot increase your revenue by increasing the price, because people will not buy iPhone. They have so many alternatives, they will choose alternatives, or even they will not buy iPhone because they can live without iPhone. In this case, demand is sensitive to changes in the price. That is, percentage change in the price produces a large percentage of change in demand. When there is elastic demand, the price increase will decrease revenue. So, and when elasticity of demand equals to 1, the demand is described as having unit elasticity. This means that percentage change in price produces the same percentage change in the demand. Suppose a price demand equation is this: x equals to f of p. So it means that E of p is 1875 minus p square. So determine whether demand is elastic, inelastic or unit when price is this. We first find E of P. E of P will be calculated through this formula. So this is your f dash of P. We will find f dash of P is minus 2P is f dash of P. F of P is 1875 minus P square. You can substitute them into this equation and you will get this. Now when P is 15, you see that what is the behavior of demand. It is less than 1, it means that demand is inelastic. It does not matter either you increase the price or decrease the price, demand will be same. For P equals to 25 equals to 1, so demand has unit elasticity. If you increase the price, demand will be increasing at the same rate, and so on. If P is 40, it is greater than 1, so in that case demand will be inelastic. If demand is inelastic, consumers tend to continue to buy even if there is price increase, and in this case the price increases will increase revenue and price decrease will decrease a revenue. And if demand is elastic, consumers tend to reduce their purchase if there is a price increase. In this case, a price increase will decrease revenue and a price decrease will increase revenue. Elasticities differ for different products, as I have already explained. When there are close substitutes for a product, or if the product is luxury rather than a necessity, the demand tends to be elastic. Jewelry, furs and furniture tends to have a high elasticities, and large price increases tend to decrease demand, while large discount on the price tend to increase the demand. On the other hand, when there are no close substitutes of the product is necessary, the demand tends to be inelastic. Milk, sugar, like as I said, for your living, these things are very important to live.